Okay, so our last section for Chapter 7 is 7.6. And it's similar to what we did in Section 7.3. We're going to solve trig equations, except now we're going to do it algebraically instead of graphically.
Is the take-home going to be on sections 7.5 and 7.6, or is it going to be in 7.5, 7.6, and 8.1?
Everything up through tomorrow.
Oh.
Yeah. So when we're solving a trig equation using algebra, okay, some of the techniques we can use are to factor. Okay, and you factor a problem with trig just like you would factor a problem with algebra. Okay, same idea. Rewriting using one trig function. So if you get a problem that has different trig functions, okay, like this one. You've got cosines mixed with sines. You can't do anything with that. You have to have all the same trig function. So we might want to think about how can we rewrite this using something else we know. Okay, so anytime you want to solve a trig equation, try to get it all in the same function. Okay, and the last thing we can do is the quadratic formula. Okay, so remember what I showed you earlier? Basically, anything that fits this pattern is a quadratic type equation. You can put anything you want in the box. You could put just a basic x. And that's kind of what you do in algebra 1. Or I could put sine x. As long as you have the same thing in each box, and the first one is raised to double the power of the middle one. Okay, it has to be double the power of the middle one. And the last term has to be just a number. Okay, that's a quadratic type equation. Okay. So we'll do all three of these things. And sometimes we'll still use the calculator to help us just because we're solving it algebraically. Doesn't mean we can't type things in. We're just not going to be really using graphing at all. Okay, so you can use a graphing calculator, but we won't be graphing anything on it. All right, so this one says to find all solutions between 0 and 2 pi. Yeah? So if you're finding solutions between 0 and 2 pi, you just are finding specific numbers. Bless you. Okay. You don't have to put plus 2 pi n on your answers. Okay? That's if you're trying to find all solutions in general. We're finding specific ones between 0 and 6.28. So we'll just write them all down. All right, so this is a problem where I'm seeing an exponent of 2. This has an exponent of 1. But is that a quadratic type equation? Why not? This exponent is double that one. It's not the same. All right, this is like saying 2y squared plus x plus 1 equals 0. You don't have all the same letter. Okay, you've got different things. So generally when you have something like this, the goal is to take the one that's squared and rewrite it in terms of the other one. Okay, and here's my hint. That's a Pythagorean identity. Sine squared plus cosine squared equals 1. So what I just circled, I want to replace cosine squared. Using this identity, what is cosine squared equal to? 1 minus sine squared. Now, my first term has the sine function. My second term has the sine function. And now it's a quadratic equation. Okay. I've got to do a little bit of distributive property and simplify some things. But the point is, you've got sine in both spots now. Any questions on that? All right, so now it's 2 times what you just substituted in. So we have to multiply that out. Let's see. What's 2 times 1? 2. And then 2 times negative sine squared is just negative 2 sine squared.
Would it be 2x, or does that x count with the sign? Maybe negative minus 2 sine squared 2x, or just...
Nope. Just minus 2 sine squared x. And now you do have some like terms you can combine here. What can you combine at this step? Yeah, you have a positive 2 and a positive 1. So we have negative 2 sine squared x plus sine x. And what's 2 plus 1? 3. Okay. Now, does everybody see how we have a quadratic there?
Yep.
Okay, there's two ways we can solve it. We can either try to factor it, or we can use quadratic formula. This one does factor. What's the only thing that's a little weird about factoring this one? Yeah, when we factor, we kind of like if you had a problem like this, negative 2x squared plus x plus 3 equals 0. This is exactly what that equation is. Same idea. We just don't like to have a negative with the squared term. So what can I do to get rid of that negative? It's okay if I have negatives in other places. And how would you take it out? You could factor it out or divide by negative 1. Yeah, just divide everything by negative 1, and all it does is this. 2 sine squared x minus sine x minus 3 equals 0. It changes the sign of everything. You don't have to do that, but generally when we factor, that's how we do it. All right, so now we're going to try to factor this equation, just like you would factor this. 2x squared minus x minus 3 equals 0. If you can factor what I just wrote on the right, you can factor this one. It's the same idea. Okay. What's going to be my first term? 2 sine x. And what about my first term in the other parenthesis? Yep, just sine x. Just like if you were factoring that other one, it would be 2x and x. Same idea. Now, what about my signs? I have a negative middle and a negative constant. Yep, you need one of each. And it does make a difference which one you put where. I'm just going to put them in the order Denver said. He said a negative and a positive. If that doesn't work, we can always switch them. And now I need two numbers that multiply to give me 3. 3 and 1. Again, it does matter where you put them. I'll try them in the order John said. So 2 sine times sine is 2 sine squared. What's 2 sine times 1? 2 sine. And negative 3 sine. So 2 sine minus 3. 2 minus 3 gives me a negative 1. And then negative 3 times 1 is negative 3. Okay, so we factored that correctly. Any questions on that? Okay, now, once you have these two factors, what do you do with each of those factors? You do what? Set them equal to 0. So 2 sine x minus 3 equals 0. Or, there's another answer, sine x plus 1 equals 0. Okay, let's start with the one on the left. What would be the two things I would have to do to get sine x by itself?
Add 3 to both sides and divide by 2.
Add 3, divide by 2. Yep. What's 3 divided by 2 as a decimal? 1.5, yeah, 1.5. So the next thing you would kind of think about is this is, if you want to think about it graphically, this is saying, where does the graph of sine hit 1.5? Think about, when does the graph of sine reach a height of 1.5? It doesn't, right? What's the highest that it does reach? It only reaches 1. If you didn't notice that, you probably would have tried this. You said, well, to get rid of sine, I'll take the inverse sine of each side. But then when you type that in on your calculator, you're going to get no solution. There's no answer from that part. It doesn't mean there isn't an answer from another part. Okay. So now, how would we get sine x by itself here? Subtract 1. And now, to get x by itself, you would take the inverse sine. Now, is sine going to hit -1 at some point? Yeah, and I want to know where it hits -1 between 0 and 2 pi only. All right? So the easiest way we can do that is if you can type it in, but the problem is it's going to give you a decimal. If I do it in radians. Okay, it's -1.57. But if we do it in degrees, you're going to get a nice answer, and then we could change to radians if they want us to. Whoops. Type in -1 and then inverse sine. Okay, it's at -90. Now, what did the problem say they want the answer between? All right, so yeah, between 0 and 2 pi. So first of all, eventually I'm going to change that to radians, but I also want to make that positive. Yeah, you can just add 360. So that's my answer in degrees, 270. What's 270 degrees in radians?
Pi over 2 or
3 pi over 2. Yep. That's why I do it in degrees first, because if you showed me that number as a decimal, I would never recognize that on the calculator as 3 pi over 2. So I do it in degrees, and then if I need to, off to the side, convert to radians, and you get 3 pi over 2. Okay, just multiply by pi, divide by 180. Okay, so in this case, there was only one solution. We could have gotten more, but just the way it worked out this time, we didn't. Good. Any questions on that? All right, so let's try this one. Okay, now this one doesn't even tell me where to look for solutions. All it tells me in general is within one period. So before I even start the problem, I have to figure out where should I even be looking. Okay, so it's one more step than the last one. Let's find the period of sine squared. What's the period, what's the formula you use for sine to an even power? What is it?
Pi over the absolute value of b.
Yep, pi over the absolute value of b. What's b in this case? Yeah, it's just a 1. So what's pi divided by 1? Pi. So the period of that is pi. And now this is just your basic cosine to the first power. What's the period of cosine?
Pi over the absolute value of b.
Nope. It's not pi. It's cosine to an odd number. 2 pi. So what's the period of this whole entire problem? It's the least common multiple of those two, 2 pi. So now I can say, all right, I'm looking for answers between 0, that's what I usually do, and 2 pi. It happens to be the same as the last problem. All right, so now we at least know where we're going to look for answers. Now we can solve the problem. What's a little different about the setup of this one versus the setup of that equation? It's not equal to 0. So that's the first thing we should do, is make it look like the other one. And then from there, every step is the same. So how would I make this equal to 0? All right, subtract the 1. Yeah, subtract the cosine. You have to move both of those to the other side. Okay, is that a quadratic equation? No, it's not quadratic. How come? They're two different trig functions. We got to get everything the same. And what's the one that I said to replace? Nope, not cosine. Think about last time. We replaced the one that was what? The one that's what, Fred? Yeah, the one that's squared. It's usually not going to be anything other than that. Otherwise, it gets a little confusing. So always replace the one that's squared. So this time, it's sine squared. What is sine squared equal to? It's 1 minus, not quite, cosine squared. Okay, minus cosine x minus 1 equals 0. And now everything we just did is going to be the same. I'm going to do it again. Except I'm going to do two things at once. What's 2 times 1? 2 minus 1. 1. Okay, so I'm going to combine that. I'm going to do that all in one step. Now, 2 times negative cosine squared. Negative 2 cosine squared minus cosine x. And that was plus 1. Okay, everyone see how I got the plus 1? I did 2 times 1, and then I did minus 1. So I just did it all at once. Okay, if I want to try to factor that, what's generally the next thing I would do? Oh, awesome. Be our next step if we want to factor that. Yeah, divide everything by -1. It just makes this easier to factor. At least that's how you factored in Algebra 1, so we're trying to keep it the same. We always factor with the squared term positive. So I just divide everything by -1. It changes the sign of everything. And now you're basically factoring this. 2x squared plus x minus 1 equals 0. If you can factor that, then you can factor that. Okay, let's see. What would be my first term in the first parenthesis? Yep, 2 cosine. And my first term in the second parenthesis would have to be cosine. And now I have a positive middle and a negative constant. So what would I need there? Yep, you need one of each. It does matter which one goes where. If we don't have it right, we'll fix it. And 2 numbers that multiply to give me 1. 1 and 1. So if I check this, I'm going to get -2 cosine plus cosine. What's -2 plus 1? Is that what I wanted in the middle? I wanted +1. So what does that mean I have to do? Switch the signs. Plus, minus. Now I'll just check it. 2 times 1 is 2. Take away 1. 2 take away 1 is 1. So now we've got it. Okay. Next, what do I do with each thing that I just underlined? Set them each equal to 0. Or cosine x plus 1 equals 0. Okay. What do you get here if you get cosine x by itself? Cosine x would equal 1/2. And how would I get x by itself?
Inverse.
Yep. Inverse cosine. And now, before I even solve it, you're looking for where cosine equals a positive number. What quadrants does that happen in? Luke?
Yeah.
Yes, it's going to happen in quadrants 1 and 4. So we have to keep that in mind. So there's a lot of things that we've learned kind of coming together here. Okay. So I'm going to use my calculator to figure out that. Inverse cosine. I'll do this one. I can do it in radians as well if we want. So the first answer is 60. That's degrees. In radians, that would be 2 pi over 3. Okay, so 2 pi over 3. And I'm going to think of it in my head as 60 because that's easier to do in my head. When I have 60 as my reference angle, and you guys said the other answer is in quadrant 4, what's the formula that you use in quadrant 4 to get the other answer? Subtract that from 360. So what's 300 minus 360 minus 60? 300. So now 300 in radians. If you're not sure, just do it off to the side. Multiply by pi, divide by 180. Let's see. 6 goes into both. 6 times 5. Yeah, and then 6 times 3. So 5 pi over 3. If they don't ask to convert to radians, you don't have to do this last step. But since our interval was 0 to 2 pi, that's radians. Okay, so we get 2 answers. And how about this one? Cosine x would equal -1. We just did this, I think, or something very similar in the last problem. Okay, the inverse cosine of -1. All right. So 1 negative inverse cosine. You get an answer of 180. Now, that's not in a quadrant, so you don't have to worry about a second answer. Okay, if you get an answer that's right on an axis, that's it. Okay, there's no second answer. What's 180 in radians? It's pi. In fact, I can put equal signs here. These are exact. I didn't round anything off. Okay, so this problem had 3 answers. And to double check, well, you will have time because it's a take-home, you could double check by graphing. Okay, but if all I saw was these 3 answers, and I didn't see any work, then you wouldn't get credit for them. Okay, so you gotta show me because there's no way you could figure these out in your head. Not with all this work. Okay, so you might, if you need a separate piece of paper, just show your work on that. Good. Any questions on that one? Okay, let's try another one. This you don't have to write down. I'm just reminding you that we are only finding specific solutions. Okay, we're not putting plus 2 pi n on any of our solutions. Okay, we've done that before, but not now. So the set of complete solutions is generally you find a specific solution and then put plus 2 pi n. Or actually, in general, you put plus the period times n. We're not doing that in this section. Okay? But we've done that before. Okay, again, finding all solutions between 0 and 2 pi. Okay, so this time, at least they told us where to look for the answer, so we don't have to figure that out. This one's a little tricky, but a hint I'll give you is you want to change this. Does anybody remember what you can change tangent to? Okay, we can change it to sine and cosine somehow. What's the formula? That's cotangent. Sine divided by cosine. Now, is that a quadratic equation? No. but it will be. Anybody see something else I could do on both sides to simplify what I have there? And it's going to start to lead me towards a quadratic equation? Subtract what?
Well, like, move over the
Times cosine.
Yeah, well, eventually we're going to have to move some stuff by subtracting, I think. But what I would do first is what John just said. Multiply the left by cosine and multiply the right by cosine. John, what happens when you do that on the left?
Becomes 3 cosine squared x.
Okay, on the right.
Yeah.
What happens on the left?
It becomes sine x.
That cancels out, and you have sine x. Now, this problem is basically similar to this problem. You've got something squared on one side, something on the other side that's not squared, and we're going to do the same stuff we just did in the last problem. Okay, so Bria said in general it's good to move all things to one side. Should I move the cosine squared to the left or the sine to the right? Which one? Yeah, I would move the sine because then the cosine squared will stay positive. So Fred, how do you move this to the other side? Do what? Yep, you're going to subtract it. So 3 cosine squared x minus sine x. Okay, we're starting to look more like a quadratic, but is that a quadratic? No, why not? You still have different trig functions. So we have to replace one of them. What's the one that I replace? Replace the one that's squared. Okay, so inside the parentheses, I need something that's equivalent to cosine squared, and it has to have sine in it. Yeah.
1 minus sine squared.
Yep, 1 minus sine squared. And now we're doing all the same kind of stuff we've done before. Even though we tried really hard to keep the squared term positive, it still ended up becoming negative. So we're going to have to do that trick by dividing everything by -1, eventually.
Is that like a general rule, like always change the one that's squared?
Yes.
Okay.
So we've got 3 times 1 is 3, minus 3 sine squared x minus sine x. And what can I do to make the squared term positive? Yeah, multiply or divide everything by -1. And at the same time, I'm going to write this in the order we normally do, which is squared term first, sine term second, and the number by itself last. Now, this is a problem that you would be solving in algebra. It would look more like this. And you can try really hard to factor that, but you're not going to be able to. Okay, this is not factorable, no matter what you try. So rather than wasting time trying a bunch of things to realize it doesn't factor, I'm going to go right to another method. Okay, what's a different method I could use? Quadratic formula. There's 3 things I need to identify. If I'm going to use quadratic formula on this, what's A? 3? B, and C. Right, so let's go through the quadratic formula. And at the end, we have to remember what we're really solving for. If you were doing this one, you'd be solving for x. But we're not doing that one. Okay? So we'll come back to that in a second. Negative b plus or minus the square root of what comes next? B squared.
Minus 4ac.
4ac divided by 2a. First thing I'm going to do is I have minus a minus. So that's going to become a plus. So 4 times 3 times up. Now that's a positive 3. So 4 times 3 is 12. What's 12 times 3? 36 plus 1. Okay, so now if you were doing algebra, that's your answer. You would circle this and you would stop. And you put x equals. But that would be if we were doing this problem. That one. In this case, it's not x equals. What do I put right here? We just solved for the sine of x. You're always solving for whatever is right there. That part that's in the middle. Okay, so now my last step to get x by itself would be to do what? Yeah, take the inverse sine of that number. -1. And now I want to figure out how many answers we have. We could have up to 4 answers. Because if this is equal to a positive somewhere, we could get 2. And if this comes out to a negative somewhere, we could get 2. But if it comes out bigger or smaller than what number, I can ignore it. If it comes out bigger than 1, ignore it, and less than -1. Okay, let's check. Let's take -1 plus the square root of 37 and divide by 6. Is that going to work when I type it in? Yeah, the plus is going to work. Let's try the minus. -1 minus square root 37 divide by 6. Is the minus going to work? No, because if you try to take inverse sine of -1.18, you're going to get no solution. So you don't have to worry about the minus. And I'll just put that it's less than -1, which means no solution. So don't do the minus. All right, so we do need to do the plus. So x is about, we're just going to round this off, second inverse sine of -1 plus square root 37. You know what I would do? Put that in parentheses. Or if you don't want to do that, do it in 2 steps. So it's going to do -1 plus the square root of 37 first. Then it's going to divide it by 6. And then it'll take the inverse sine of it. Okay? Right, so in radians, one answer that I get is 1.01. Now, we're looking for where sine equals a positive. Okay? -1 plus the square root of 37 divided by 6. That was a positive number. What other quadrant is sine positive? 2. What's your formula to get an answer in quadrant 2? Oh, Ian, remember the formula? So our reference angle is 1.01. Yep, but we're looking for the formula to find an answer in quadrant 2 using that reference angle. If you were doing it in degrees, it would be 180 minus the reference angle. Yep. What about in radians?
Pi minus reference angle.
Yes. Pi minus the reference angle. Okay, so 2.13. So there's not a lot of new stuff in this problem, but it is a lot of stuff that we've talked about before. You've got to know where those trig functions are positive and negative and what you do in each quadrant. So make sure you have this diagram and you know it. Okay. Quadrant 2 is 180 minus, quadrant 3 is 180 plus, quadrant 4 is 360 minus your reference angle, if you're in degrees. Okay, let me just double check book 1.01 and 2.13. Yep, so those are both correct. This is kind of similar to the other ones. I don't think there's anything new here that we didn't really do in one of the other examples. What would be the first thing you would have to do here? Okay, get everything on one side, and then what would you do after that?
Convert it to cosine.
I wouldn't convert to cosine. I would convert cosine into sine using your 1 minus sine squared. Okay, and then go from there. Maybe it would factor, maybe quadratic formula. All right. Okay, let's try this one. Now, when I look at this one, I'm starting to think it could be a quadratic type equation because I see one exponent that's double another one. But why isn't it quadratic right now? Yeah, they're two different. One's tangent and one's secant squared. Does anyone remember the identity that involves these two? It's not sine squared plus cosine squared equals 1. It's the next one. Yeah? 1 plus tangent squared equals secant squared. So what I would do is replace secant squared with 1 plus tangent squared. And then you're going to have all tangents in the problem. Okay? So you have to know that Pythagorean identity. Okay, so we get 3 tangent to the 4th. That just stays the same. And then I'm going to have 1 plus tangent squared. So what's 1 plus tangent squared? 2 plus tangent squared. All right, and now we're going to solve this just like every other problem. So the first thing we do is get it equal to 0. You always like the highest term to be a positive if you're going to try to factor. If you're going to use quadratic formula, it doesn't really matter. Okay, but I want to keep this positive. So how would I move everything to the left? Well, Connor. How would I move those terms to the left? Subtract tangent squared. And subtract 2. Perfect. So now I want to try to factor that. And it's basically like factoring this. 3x to the 4th minus x squared minus 2 equals 0. Okay? If you can factor that, then that's the same thing. What would have to be my first term in the first parenthesis? Three what? Not tangent. Because you're going to have to put something here and then something here so that you multiply them together to get tangent to the 4th. Right? Yeah, you put 3 tangent squared. And then what would you put in the second one? Just tangent squared. So that's going to give you 3 tangent squared times tangent squared. That's 3 tangent to the 4th. How about my sines? Plus and minus? Minus minus or plus plus? No, it's not minus minus. Yeah, it's one of each. It does make a difference where you put which. If you get them wrong, we've already done that once, you just switch them. And now 2 numbers that multiply to give me 2. 2 and 1, I would suggest doing it like that. So now you've got 3 times negative 1, that's a negative 3. 2 times 1 is 2. What's negative 3 plus 2? Negative 1 tangent. Yep, that's exactly what we wanted. Okay, so it factored, so we didn't have to use quadratic formula. Okay, what do I do with each one of these factors? Set them to 0. So 3 tangent squared x plus 2 equals 0. Or tangent squared x minus 1 equals 0. What would tangent squared x equal here?
2
No, not 2 over 3. Negative 2 over 3. And that's very important. You would have to subtract the 2 and then divide by the 3. And now what would your next step be? Not yet, because you don't have the tangent function by itself. It's already squared. So what's square root? Yeah. What's going to happen if I take the square root on both sides? I mean, this would cancel. What's the square root of negative 2/3? It's no solution. That's imaginary. Okay, so because you have the square root of a negative, we can stop with that part. That's why I said the negative was important. Okay, and now the other one. How would we get the 1 on the other side? Add it. And what would your next step be? Square root. And that would mean tangent x equals plus or minus 1. So we're going to get two answers out of that. As long as the answers are between negative pi over 2 and pi over 2. We'll see if they are. And now my last step. Take the inverse tangent. Okay, so let's see what we get. It's a second inverse tangent of 1. That's, well, if I did it in degrees, you would probably recognize it as a nice answer. It's 45 degrees, which is pi over 4. That's negative 90 to 90. Is 45 degrees between those two numbers?
Yes.
Yes, then we write that one down. And let's do inverse tangent of negative 1. That's negative 45 degrees. Is negative 45 degrees between those two numbers? Yes, then we write that down. Split. And that's it. Okay, we could have gotten a couple other solutions, but this time it just worked out that they would be imaginary. We're not doing imaginary solutions. Any questions on that one? It does take a little practice to get good at these. Let's finish up with, we're not going to probably get to the double angle one, but let's try this one. Okay, so this is a factor by grouping. So factor by grouping means factor what you can out of the first two terms, factor what you can out of the second two terms, and then hopefully something nice will happen. If I'm telling you to factor by grouping, something nice will happen. Okay. What do the first two terms have in common? Yep, cosine x. If you factor that out of the first term, what's left? Two cotangent. Because if you distributed it back out, you'd go right back to what you started with. And what if you factor it out of the second term? 3. Because if you distribute it back out, you'd go right back to what you had. What do the next two terms have in common? Nope, they both don't have a cotangent, because one of them is just a 9 and one of them is 6 cotangent x. Yeah, they have a 3 in common. So let's factor out a positive 3. What would you have to multiply 3 by to make it 6 cotangent x? 2 cotangent x. And what would you have to multiply 3 by to make it a negative 9? Negative 3. So what just happened is when you factored out what they have in common, you ended up with that. So now, what does the first term and the second term both have in common? Yeah, what I just underlined. The 2 cotangent x minus 3 and another 2 cotangent x minus 3. Okay, so you're going to factor that out. If you factor out 2 cotangent x minus 3, what's left in the first term? Just the cosine x. And what's left in the second term? Just the 3. And now we've got something times something equals 0. So what do I do with each of those factors? Set them to 0. What would cotangent x equal? We'd have to add the 3 and divide by 2. I'll come back to that in a second. What would cosine x equal? Negative 3. If you try to take the inverse cosine of negative 3, you're asking where does the graph of cosine hit negative 3? Never. There's no solution from this. So you don't have to worry about that one. Now, this one, you have cotangent. How would you get rid of the cotangent function? What's the opposite of cotangent? Or the function that cancels it out? Yeah, it would be the inverse of cotangent. Do you have a button for inverse cotangent? No. So what function is very similar to cotangent, but tangent? What's the relationship between them?
1 over tangent is cotangent.
Yeah, you flip. So if the cotangent of x equals 3/2 in this problem, what does the tangent of x equal? 2 over 3. And now I can do what on both sides because I have a button for it? I can do the inverse tangent. Right? So now when you type, just to save us, when you type that in, you get 2 answers. That is going to give you 0.59. And what other quadrant is tangent positive in? Yeah, in the third. So what's the formula to get an answer in the third quadrant?
180 or 5.
180 plus that. Yep. So the other one is 3.73. Okay, so those are some of the trig type problems you'll have in the homework. They pretty much all, every time, are going to either be quadratic formula or factor. Okay. If you get stuck on one that has a double angle, don't worry too much about it. We can look at one like that tomorrow when we go over homework. And that was really the last type of problem. So not every problem is going to be that long. There are some I gave you that are review. So they're very, very simple ones. In fact, 1 through 9 is either very simple or they've already factored the whole thing for you. After number 9, those are the kind of like the ones we did in class. Okay, but 1 through 9 are easier than what we did in class. Right, so we'll take a look at that tomorrow.